If you go back to the first slide, where we start our discussion of regression and examine the scatter plot, you should notice that not all the dots on the scatter plot align onto the regression line. There are some dots that fall away from the line. The regression procedures described on the previous slides determine the straight line that predicts y from x. Except in rare cases, the actual data points will not fall precisely on the regression line. That is, there will be some error in estimating y-scores. The regression line is selected to minimize error, but some error almost always exists. We quantify what error exists in the regression equation by calculating the standard error of estimate, or C, and we use the value we compute with the C formula, much like we use the standard deviation. Click on the worked example of a regression link that is located next to the link for this video. It provides an example of how we use the regression and standard error of estimate formulas, and we will be using the standard error of estimate formula shown on the lower right of this slide. As you examine the worked example of a regression, here is the scenario associated with that data. A regression equation was computed from a data set involving 5 students, their SAT scores, and their freshman GPA scores. The regression equation is y hat equals 0.012x minus 11.638 or 11.64. A student named Sarah had an SAT score of 1110. Substituting Sarah's SAT score for the x value in the regression equation works out to y hat equals 0.012 times 1110 minus 11.638, which results in a predicted GPA for Sarah of 1.68. As a predicted value, it is the best estimate of Sarah's GPA that is possible. However, we can refine our estimate by using the C, which is computed as 0.77. Using the 0.77 C, the same way we use a standard deviation, we bracket Sarah's predicted GPA, and we can subtract 0.77 from it and add 0.77 to it, which gives us a range of values of 0.912 to 2.452. Recall that approximately 68% of the cases in a normal distribution fall between plus and minus 1 standard deviation of the mean. Therefore, while one would predict a specific grade point average of 1.68 for Sarah, in 68% of such cases like Sarah's, the interval between 0.912 and 2.452 will contain Sarah's actual grade average. Finally, a little bit about the relation between correlation and regression. We use a different procedure in the Pearson's R formula than we use to calculate the slope in regression. So we come up with different values. The correlation R and regression slope are conceptually related, but not equivalent, because of the different mathematical procedures used to calculate those numbers. Also, you can correlate X with Y or Y with X in the Pearson's R formula, and you would still come up with the same number. Not so in regression. Predicting Y based on the X values will give you a different number than if you predicted X based on the Y values.